Hello everyone, this is Kalpana here. In this video, we are going to see few problems from Laplace transform. So let's get going. So here we are going to use the three formulas. Okay. So I'll begin with the first one. Prove that L of cos AT equal to S by S square plus A square and L of sin AT equal to A by S square plus A square. We know that Euler's formula e power ix equal to cos x plus I sin x, right? Then e power iat will be, for x equals to at, will have cos at plus I sin at, right? Then L of e power iat will be L of, since e power iat is cos at plus I sin at, right? We can write this as L of cos at plus I into L of sin at. Now we have L of cos at plus I into L of sin at equal to L of e power iat, right? Then L of cos at plus I into L of sin at equal to, I'm just writing this as it is, right? We can write e power iat as e power ia into t. Since we know that L of e power at equal to 1 by s minus a for s minus a greater than 0, right? So here just compare e power iat with e power at, then for a equal to ia will get 1 by s minus ia, right? Here let's multiply and subtract s plus ia. Okay, see, in the denominator we are having s minus ia, just change this sign, we'll get s plus ia, multiply and divide s plus ia to this fraction. This gives us s plus ia by s minus ia into s plus ia, or we can write this as s plus ia by s plus ia into s minus ia, right? This equals to s plus ia by, this of a plus b into a minus b form, so we can write this as a square minus ia whole square. We are having ia whole square, right? We can write this as I square into a square. Since we know that I square equal to minus 1, then we'll get I square is replaced by minus 1 into a square gives us minus a square. So we can write ia whole square as minus a square in the next step. So the reduced step is L of cos at plus I into L of sin at equal to s plus ia by s square minus ia whole square. Again, we can write the RHS part as s square minus ia whole square is replaced with minus a square, right? This gives us s plus ia by s square, minus into minus plus a square. See, in the numerator we are having two terms, and in the denominator we are having s square plus a square, which is treated as one term. So we can split the total expression into two terms. We'll get s by s square plus a square plus I into a by s square plus a square. Now equate the real and imaginary parts. By equating real part, we'll get L into cos of 80, that is L of cos 80 is S by S square plus A square, and by equating imaginary part, we'll get L of sin 80 equal to A by S square plus A square. Equating real and imaginary parts, by equating real part, we'll get L of cos 80 equal to S by S square plus A square, and by equating imaginary part, we'll get L of sin 80 equal to A by S square plus A square, right? So therefore, L of cos 80 equal to S by S square plus A square, and L of sin 80 equal to A by S square plus A square. We have proved the first one. Now let's solve these problems. Coming to second one, find L of sin 2t. Since we know that L of sin 80 equal to A by S square plus A square, right? Now compare sin 2t with sin 80, then for A equal to 2, we'll get A, that is 2 by S square plus 2 square, which is equals to 2 by S square plus 4. Therefore, L of sin 2t equal to 2 by S square plus 4. Now coming to third one, find L of sin 5t. Now compare sin 5t with sin 80, then for A equal to 5, we'll get, just substitute A by 5, A, this 5, then we'll get 5 by S square plus 5 square, which is equals to 5 by S square plus 5 square is 25. Therefore, L of sin 5t equal to 5 by S square plus 25. Now coming to the fourth one, find L of sin pi t. This equals to, now compare sin pi t with sin 80, then for A equal to pi, we'll have A, that is pi by S square plus pi square for A equal to pi. Okay. Now let's solve problem number 5 and 6. Begin with 5. Find L of cos 2t. Since we know that L of cos 80 equal to S by S square plus A square, right? Just compare cos 2t with cos 80. Then for A equal to 2, we'll have S by S square plus A square, that is 2 square, which gives us S by S square plus 4. Therefore, L of cos 2t equal to S by S square plus 4. Now coming to the sixth one, the last problem. Find L of cos 3t. Compare cos 3t with cos 80. Then for A equal to 3, we'll get S by S square plus 3 square, which is equals to S by S square plus 3 square is 9. Therefore, L of cos 3t equal to S by S square plus 9. So we have seen few problems from Laplace transforms in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.